So just to get us started with a new concept, we're moving on, and we're about to embark on quadratic equations and functions. But before I do, I'm just going to give you a little bit of back history as to where we see quadratic functions in the world and in all around us. And as you guys know, everywhere I go, did I just rap right there? Let's go. As you guys know, everywhere I go, I usually see mathematics everywhere. So, in the past, who's seen those movies of the medieval times with kings and queens and knights and all that? Have you guys seen some of those movies? Well, in those movies, sometimes you see a part of the movie where the king is talking to some of his knights, and he has a special room. I don't know what they call it. I think it's the king's chambers or something like that. And in there, the king usually has a table for, let's see, a table set up like this, and all the knights, they're seated over here on the sides. And the king has his chair right here in the back. Let me just make it obvious to make sure that we understand that it's the king's chair. It's not a bouncy house, no. Wow. The king's chair. Oh, you were, oh, okay. So here's the chair for the king, and of course, he's seated here, right? Here's his crown. There it is. Boom. He's happy because he's the king. There it is. All right. Well, back in those days, check this out. Back in those days, kings have a lot of people that are their right and their left hands, meaning people that are close to him that advise him for whatever. And one of those advisors back then were mathematicians. And in those days, some mathematicians, they were considered wizards. So guess what happened to some of those? Exactly. They got killed because they thought they were wizards. But in fact, they were just using mathematics. For example, let's say the king was here, and then all of a sudden here walks in somebody, and they're like, messenger, king. The messenger comes over and says in his ear, king, invading troops just arrived. Let's say we have a king here in Imperial. Let's see who wants to be the king. Nanelle's the queen. So she's the queen, and they come and tell Nanelle, we have invading troops that just arrived in San Diego. And Nanelle will be like, send a dispatcher to confirm. And all of a sudden, she sends Isaac in a horse. Boom, Isaac gets on, takes off. And the dispatcher does not stop, not even for food or for the restroom, until they accomplish the mission that they were sent for. However, in between all that, as they were being dispatched, the right hand of the king, which is right here, this person, he's a math person, he tells the messenger, when you're there, once you arrive, I want you to do the following. I want you from afar, look at the troops as they're marching. I want you to count to 30. You know, and of course, he told him, and count it like this: 1 Mississippi, 2 Mississippi. No, back then it wasn't Mississippi's, right? It was like 1, 2, 30 seconds. But as you're counting, I want you to count how many steps they take. And he said, okay, so count 30 seconds and count how many steps they take. Yes, bring me that information. So then the scout will go out there to San Diego. So Isaac went out there. He was behind the bushes, seeing the troops march, and all of a sudden he started going like this with his arm. And then counted the amount of steps, came back to confirm, yes, Queen Nanelle, we are being invaded. And then, all right, talk to the mathematician Devin. So Devin's a mathematician, so then he's all right, they're taking so many steps in those 30 seconds. Devin, being a mathematician, he was going to use the formula rate times time equals distance to predict how long it was going to take them to arrive in the kingdom. And then once it happened, Devin got up and Queen Nanelle, the troops are going to arrive in 3 days. And then Queen Noble, okay, get our perimeter secure, blah, 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 and all this and that. And then when they arrived, all the people were like, Devin, he sees the future. Right? In those days, that's what it was considered. Well, guess what? A lot of mathematicians were persecuted and executed because of the fact that they knew mathematics. However, check this out. Now, I just wanted to get you, like, in that time period. Now, with all that going on, the mathematician told the king, okay, king, let's build here in this room, get a construction crew, and behind you, let's create a little indentation on the wall that looks like this, like a circular part behind you. And you're saying, and here's the wall, here's the flat wall. And his chair can go into the wall a little bit. Does everybody see that? So imagine this is a flat wall, and I get like one of those big balls and hit the wall, and it creates an indentation on the wall, right? But it's a little bit further back where he can actually fit his chair in there. Well, the mathematician figured out that sound travels in waves. And when everybody spoke here in this room, those waves came in and hit the wall in that curvature. Anything that hit the curvature, it doesn't matter where it hit, all the sound, when it bounced back, guess where it bounced? It bounced to the king or queen, to the center. That's why he's like, oh, Marissa, you're talking snap about me? You see what I'm saying? The king or queen can hear from far away because they had that part in the back. This indentation, these curves, is what we call quadratic functions. And they're found everywhere. Check this out. Now in the future, fast forward. Who's seen this? Who's gone to orchestras or seen this in theaters? Who's seen it in movie theaters and now they have a little bit of a curve to it because sound and images travel in curves. Here's a curve right here. Here's a curve over here. How about who's seen these out on satellites? Yes, these satellite dishes are curved, and let me show you how this works. Satellites are sent up to the space, and they look like this. It's let's say a rectangular sphere like this, and it's got like some wings, something like that. These wings reflect signals, and then they send a signal to Earth. When signals come out of it, they come onto Earth. When it hits something flat, it stops. But when it hits something curved like this, doesn't matter where it hits it, guess where it's going to send the signal? To the center. And what's in the center? These things called the receivers. Those receivers have cable to it, and it becomes Wi-Fi, it becomes cable TV, it becomes cellular signals and stuff. That's how those work. We've also seen it now. They're starting to sell TVs that are curved. Who've seen that on the market? Because they're saying, well, if it works with sound, it works with image. Also, we can curve it kind of like the eye. The eye is curved, so let's mirror that same idea with TVs. Now, let me show you where it's seen in action. Where do we see these kind of curvatures in action? Let's see. Basically, right now, when it goes through the ride, you see the curvatures represented in the entire ride. Hold on, let me get ready. So, let's go. You see all those curves? All those are quadratic functions. If you didn't see it, just try backwards. Yeah, let's go. Look at that right. You're gonna see some curves right there. Do you see them? Over there? Yes. All those are quadratic functions. So when designing these guys, engineers use physics, use a lot of laws of science, of gravity, of motion, and stuff like that. But they also use uh, basic algebra functions, what we're going to learn now. Now, if you don't see it, here, let me show you. Check this out. How are they going to look now on paper? Like this. Let's go from the corner. And that's what we're doing today. These are called quadratic functions. So with that said, our objective for today, I can solve quadratic functions by graphing. Let's read together. 1, 2, 3. I can solve quadratic functions by graphing. So, quadratic functions by graphing, we're starting a new concept. That's why you do need a Ferrier model. What are quadratic functions? Let's find out. Quadratic functions. Oh, before I continue, at the bottom of your summary section, I want you to write this question. What is the solution to a quadratic function? We're going to answer that question at the end. What is a solution or the solution to a quadratic function? What is the solution to a quadratic function? What is the solution to a quadratic function? What is the solution to a quadratic function? We'll answer that at the end in your summary section. Move on to the Ferrier model. Quadratic functions, what are they? A function in y form in which the highest power of the variable is 2. A function in y form in which the highest power of the variable is 2. Quadratic function, a function in y form in which the highest power of the variable is 2. Examples, f of x equals 2x squared, y equals 2x squared, y equals x squared plus 2, and y equals x squared plus 5x plus 6. Copy that, and then we'll go over it together. All right, let's see. According to the definition, quadratic function, a function in y form. All right, let's see. Are all of these in y form? Yes, except for this one is in function form, that function notation, which is f of x, but we know that this is the same as what? Y, okay? And the highest power of the variable is 2. So what is the highest power here? 2, 2, 2, and 2. All right, makes sense. All right, let me show you non-examples. What are not quadratic functions? Here we go. Y equals 3x plus 2, y equals x cubed plus 9, and y equals x squared plus 5x plus 6. As you're copying those, start thinking. This first one is not because of this, the next one is not because of this, and this last one is not because of this. All right, talk about it. Why are these not quadratic functions? Why are these not quadratic functions? All right. Why is this first one not a quadratic function? Ryan? The power of the variable is not 2, it's a 1. Therefore, what is the name of this one? Hey, Leanne. That is correct. Linear equation. We just finished those, didn't we? Because they make a what? A straight line. So the line, if we graph that one, will look something like this. All right. Hey, Leanne, pass to someone. Mel, how about this one? Why is this not a quadratic function? The power of 3. So if this one's called a quadratic function because it's the power of 2, tell your neighbor the name of this one. That is correct. Cubic function. Makes sense, right? And that graph looks like this. It starts off straight like this, but then all of a sudden it curves, and then it comes back up like so. Okay? All right, Mel, pass to someone. The last one. It's not in Y form, or it doesn't have an equal sign. Therefore, what do we call this, Fatima? Quadratic trinomial. Okay, that's the proper name. But in the realm of everything we've seen throughout the year, what is this? Is this an equation? Is it a function? What is it? That is correct. These are expressions. Bam, Fatima from the corner. All right, so with that said, come up with some hashtags as to what quadratic functions are, please. All right, Fatima, pass someone. Nanelle, hashtag. Wow. Oh my goodness. Woo. Bree. The other Bree. Y form only. Julian. No 3D glasses. Okay. Oh, I'll stop right there. One more? Okay. Hashtag 23 the best. And we'll stop right there. Steps, you will come up with the steps at the end, so make sure you keep focus as to the process that we're going to do. Okay? All right, get your graph paper in front of you. The top left, I want you to copy example number 1. Example number 1 at the top left on your graph, it should write solve by graphing, and copy this, y equals x squared. This is our first function. All right. It says solve by graphing, so we need to graph. Without saying anything, think about it. If I asked you to graph this, what would you do? And I'm not talking about, oh, I'm going to go to my computer or my phone and just graph. No. If I was to ask you to graph it right now, what would you do? Talk it over to your neighbor. What would be something you would do? All right. Let's see. Reagan, what would you do? Start at what? That would be correct if this was a slope-intercept form, but it's not. Brody, what did your neighbor say? That is correct. You start with a table. X, Y. Yes, this kind of table. -2, -1, 0, 1, 2. And then we get our function. Check this out. You write your function, y equals, but instead of x, you open up parentheses, squared, and we substitute values. Okay? What's our first value? -2. What is -2 squared? 4. So that goes right there. Next one. Y equals parentheses squared. My next value is -1. What is -1 squared? 1. That goes right there. We're done with that one. Y equals 0 squared. And that is what? 0. That goes right there. Finish it off, please. Oh, finish it off, please. Samantha, the last two? 1 and 4. Hands if you got that. Okay, let's plot these. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. And now we're going from left to right. Which is the farthest point on the left? This one, right? And remember, we're no longer looking at straight lines. We're looking at curves. So I go like this. Look up. I start here. Connect it to this one. Connect it to this one. To this one. to this one, go a little bit above it, and draw your arrows like so. These graphs are known as parabolas. Parabolas. Tell your neighbor the name of these. Parabolas. Parabolas. Now check this out. We're not done. It says solve by graphing. We graphed it, but now we need to solve. So I want you to write solution. Open parentheses. Check this out. I'm going to write 0, 0. Yeah, we'll get there. We'll get there. And I want you to highlight this one. Where's 0, 0? Right there. Okay. Go to the coordinate plane to the right. Copy example 2. Here it goes. Example 2. Y equals negative x squared. Negative x squared. All right. So to graph that, what do we do, everyone? Table x, y, and our domain remains the same, negative 2, negative 1, 0, 1, and 2. All right. So now be careful with this one. Look up to the screen. Look what I'm going to write. Y equals negative parentheses squared. What goes inside of the parentheses? Negative 2. Now check this out. If this was order of operations, what would come first? Parentheses. Next, exponent. So we're focusing here first, yes? So what is negative 2 squared? 4, and bring down the, so y equals negative 4. See what happened right there? Okay, do the next one. Y equals negative parentheses squared. My next value is negative 1. Therefore, what is negative 1 squared? 1, bring down the negative, so this is y equals negative 1. Finish it off by yourself, please. The rest, go. Yay. Okay, next value, 0, what? Esmeralda. 0. 1, what? Negative 1. And 2, what? Negative 4. Hands if you got that. That is correct. Let's plot this. Negative 2, negative 4. Negative 1, negative 1. 0, 0. 1, negative 1. And 2, negative 4. All right, let's graph this. We start farthest left. Which point is that? This one. And then we go to that one, so we're going up. So we go from here to that one, to this one, curve it, to this one. Oh, sorry. And arrows at the end. Once again, what's the name of this graph? It's a parabola. And of course, we need to write the solution. And I'm going to write 0, 0. And here it is right there. Okay, turn your paper over. Go to the new coordinate plane. Example number 3, top left. And my new function is y equals x squared plus 2x. And of course, we always start with our table. X, y, negative 2, negative 1, 0, 1, 2. All right. Now, before you start, I'm going to start you off with the first value so you can see how it's working. See if you do the same thing as I. Y equals parentheses squared plus 2 parentheses, or times the parentheses. All right. Next, what's my first value? Negative 2, negative 2. Where do I start? Exponent. What is negative 2 squared? 4 plus. What is 2 times negative 2? negative 4. Therefore, see what I did there? What is 4 and negative 4? 0. So that is the work for the first one, so I write 0. I want you to do the rest. I'll give you some time. Copy that and go. All right, let's see. Who's got a value for the y when x is negative 1? X negative 1. What is our y value? Reagan. Negative 1. Let's find out. Y equals negative 1 squared plus 2 times negative 1. This is 1 plus negative 2, which is negative 1. That is correct. Who's got the next value? Pass someone, Reagan. Samantha? 0. Hands if you got that. That is correct. Pass someone. Itself. 3. Hands if you got that. That is correct. Pass someone. Eliane. 8. Hands if you got that. That is correct. Let's plot these. 2, 0 is right there. Negative 1, negative 1. 0, 0, 1, 3, and 2, 8. What's the farthest point to the left? This one, yes? So let's start right above it and going towards this one. So I'm going to do this. And then I'm going to curve it coming up to this one, to that next one, and to the next one. Arrows at the end. Once again, when it curves like this, what is it called? A parabola. All right. Now check this out. What is the next thing that we need to write? On these we wrote solution, solution. So for this one I'm going to write, check this out, solutions. You're like, what? Yeah, watch. 0, 0, negative 2, 0. So check this out. Look at these. This was my solution. This was my solution, but this one became my solutions. Talk to your neighbor. Let them know. What was the question? The essential question? What are the solutions to a quadratic function? Let your neighbor know what they are. What are the solutions to quadratic functions? Let's see, Charlie, what do you think the solution to the quadratic functions are? Any point on the x is close, because any point I can choose all these other ones, and those are not solutions. Close. Pablo. Reagan. Fatima. Have to have a 0. Yeah, and by the way, these are known as zeros. We're close. What's a general term for these? Jason. If you were to tell someone the solution to a quadratic function are what? Okay, Mel? Plots on the x, also known as the x-intercepts. That is correct. And you're also going to hear me use the word roots. So once again, what are the solutions to a quadratic function? Are x-intercepts. That is correct, where the graph intersects the the x-axis. Now your home plate for the weekend, guys, really quick. Give me a second. You're going to go to CASP.org, and it is working. I checked it already. You're going to go to practice and training tests. You're going to go here to the happy student taking the test, and then you're going to go to log in. You don't have to write anything to sign in. You just go sign in as a guest. From there, you go to select your grade. Choose the math practice test for 8th grade. Select. check for the sound. And then you're going to click on the green one. It's going to check it off and then continue. And then begin test now. And then you begin your test. I want you to write me the work on a separate sheet of paper. You don't have to copy everything. I want work for each problem. Okay, that's due on Monday. Good one, guys. Enjoy your home play. See you guys till Monday. Bye. Bye.